All right, I want to make a quick video on factoring quadratics. And I sort of need to start by giving you what do I do when I want to multiply two binomials. So I've got x plus a times x plus b, where a and b are just some number, doesn't really matter. And one of the ways to think about this is length times width. If x plus a were the length of a rectangle and x plus b were the width of a rectangle, to find the area of the rectangle, I would multiply length and width. And x plus a times x plus b would be the all this area in here. So another way to think about area is that the area is also the sum of the 1, 2, 3, 4 little bits. Well, what do those bits look like? Well, let's go ahead and clear all my coloring. Well, what do those bits look like? The bits look like this. This bit is x times x. This bit is a times x. This bit is b times x. And this bit is a times b. So the area can also be written as x squared plus ax plus bx plus ab. Now, normally, bx. Normally, we would then combine these two together. So whatever that comes to. And then this is the one that we usually call C in our quadratic. So we would have x squared plus bx plus c, our standard form quadratic, different b, not the same b as over here. So don't get that confused. Now, why am I talking about this? Because what if I'm starting with the quadratic and I need to work backwards? Sorry, my pen quits working periodically and I have to stick it into its little charging port, take it back out and reset it. What if I start with a quadratic, but I want to turn it into this? Well, we're going to do a backwards process. So here we go. And I'm going to use an example and I'm going to color code 6x squared minus 11x minus 10. And I want to write this as factors. So here's what I do. Thing one, I'm going to draw my rectangle. And one of the things I noticed from the previous rectangle is that the squared term always goes here, and the constant term, the one with no x, always goes there. So let's do a little color coding. We'll do that the squared term is gold. We'll do that the constant term is red. Now, what else do I know? I know that this negative 11x has to be split between here and here, but I don't know what. It could be 1 and 10. It could be 2 and 9. It could be, there's a whole bunch of possibilities, but I don't. That's what I've got to figure out. How do I split up that negative 11? So what do we do? Well, our next step is we're going to do this diamond problem. And you may remember the diamond problem, and I usually just write it as an X, is that if I have a number here and a number there, I multiply them together and write that up there, and I add them together and I write that down there. And it's a fun puzzle. You could be given X and Y, and then it's easy. You could be given the product and the sum, and you have to try to figure out what your two numbers were. And that's what we're going to do here today. So here we go. Whoop, you know what? I'm going to just leave that alone. For now, I'll leave that right there. So let's draw the diamond problem. We'll just draw the X. Now, the two numbers need to be added together. Hey, guess what in our problem is two numbers that are added together? Negative 11x. So we're going to put the negative 11x right down here. Here's what else we know, and this is where the trick comes in. These two numbers multiplied together will equal these two numbers multiplied together. So I can multiply 6x squared and negative 10 And I can put that right up here, negative 60x squared. And I get that by multiplying 6x squared times negative 10, and that goes here. So what do I need to do next? Well, I'm going to go to the next page. I'm going to recreate my diamond. Here's my diamond. I've got negative 60x squared. I've got negative 11x. I know that I am looking for two numbers that multiply to negative 60 and that add to negative 11. So here's what I'm going to do. I'm going to make a list of all the numbers that multiply to negative 60x squared. In other words, factors of negative 60. So I've got negative 60. And what could I do? Well, I could do 1 times 60. One of them will have to be negative. We'll keep that in mind. But notice that they don't add up to 11. No matter how I combine a 1 and a 60, they're not going to add up to negative 11. 2 and 30, 3 and 20. So far, doesn't add up to 11. No way to make it add to 11. No way to make it add to 11. 4 and 15. Oh, interesting. 4 and 15, if one of them is negative, can totally be combined to 11. So what am I going to put in there? Well, I see that it needs to be negative 15x and positive 4x so that they will add to negative 11. They multiply to negative 60. I'm good to go. And notice that, by the way, this is x and x, so that they'll multiply to x squared, but add up to an x. So let's go back to our generic rectangle. We'll make another copy of it here. We knew that the negative, the 6x squared was in the top left. The negative 10 was in the bottom right. We now know that we can plug in 4 and x and negative 15x. And now the question is, what goes on the outside? Because those will be our factors. So let's see, what do we got? Well, we want to find ourselves something that is a factor of 6 and a factor of 15. The only thing I can think of is 3, so I'm going to put a 3x there, which means that I have to put a 2x right there. 3x times 2x equals 6x squared, so that works. Now, going down, I say, well, 3x times what is equal to negative 15? That's going to have to be a negative 5. Moving across, whoops, that wasn't what I wanted to do. Moving across to here, 2x times something equals 4x. So my something has to be plus 2. And then just to double check, if I multiply the 2 and the negative 5, do I get negative 10? I sure do. So my parentheses, 6x squared minus 11x minus 10 equals, my two parentheses are 3x plus 2 and 2x minus 5. And I have successfully factored the quadratic. All right. Thanks for watching. Hope you learned something.